NCERT Physics Class 11th, 6th chapter, which is work power energy. So in this 6.5, the casing of rocket in flight burn up due to friction. At what expense is the heat energy required for burning? So as rocket moves up, in order to increase the speed, we need to reduce the mass of rocket. And in order to reduce the mass, the casing of rocket is burned by utilizing the heat of rocket. As heat supplied by atmosphere is not sufficient to burn the casing, so the heat which is required to burn the casing is given by rocket. So this heat is given by rocket. So second part, which is part B, in this he want to say that comet move around the sun in elliptical orbit. The gravitational force on the comet due to is not onward to comet velocity, yet the work done by gravitational force is zero in complete orbit. So as we all know that gravitational force is conservative force. Gravitational force is conservative. Gravitational force is conservative in nature. Is conservative in nature. And we know that work done by conservative force in closed path is equal to 0. So as gravitational force is conservative force and work done by conservative force in closed path is equal to 0. So in this case, the work done by gravitational force on comet will be 0, as this is conservative and work done by conservative force in closed path is always 0. Moving to C part, an artificial satellite orbiting around the Earth in a very thin atmosphere loses its energy gradually due to dissipation against atmospheric pressure. Suppose Earth is given to us and a satellite is given which is orbiting around the Earth in a particular orbit. As it moves down, when it's rotate around the planet, its speed decreases due to presence of small thin atmosphere. So as when the speed decreases, the satellite approaches near to Earth's surface. So it slightly approaches near to Earth's surface, as it is given that its speed increases as it comes closer to Earth's surface. So when it came closer to Earth's surface, suppose this is distance d between the center of Earth and satellite. So if d decreases, if distance between the planet and satellite decreases, this implies potential energy will decrease. And if potential energy decrease, implies kinetic energy will increase. As total energy remain conserved, so if potential energy decreases, implies kinetic energy will increase, and if kinetic energy increases, implies that speed decreases. So we have two factors. Due to atmosphere, the speed decreases, and due to distance, the speed increases. As it is given that the effect of atmospheric resistance is very low. Losses lets its energy due to atmosphere, however small. So the effect due to atmosphere is very less. So in order to find the net change, so net change will increase. At due to atmosphere, the decrease in speed is less, but due to distance, this increase in speed is more. So net result would be increase in speed. So as the satellite approaches the planet, its speed would increase. Last part, which is D. In D part, we have given two situation. A block of mass 15 kg is moved. In one case, it is moved on the hand of person. So the force which is acting on the block is static friction. And let's say the block move by a distance of L meter. In the another situation, the block is moving by a person which is tied to a rope. The block is moving by a person which is tied to a rope. So in this case, the force acting on the block is tension. So in this situation, the block is moving and the mass of block is 15 kg. It is given that block of mass is 15 kg and here the block of mass is 15 kg. So if the block moves by a distance of L meter, so in this situation, the work done in situation 1, which is equal to, that is static friction into displacement L. And in this situation, the work done is equal to force, that is tension into displacement L. And tension is equal to, as the block is moving slowly, so we can say that tension is equal to 15 into G into L. So this friction is equal to mu into n is equal to 15 into g, and mu less than 1. This implies that this force is less, this work done is less, and in second situation, the work done is more. So work done in second situation is greater than work done in first situation. So in first situation, the work done by static friction, which is very less, and in second situation, the work done by 15 into z is more. So displacement in first and second part are same, but in case of second situation, the force is more, so work done in second situation would be more.